Hi, it's James here again. Today I want to just go over differentiating fractional and negative powers. So like x to the something, where the something is a negative number or it's a root. First of all, I'll just write out what I know about different powers, and I'm sure you'll get to learn it pretty quickly. So say we've got x to the power 0. Anything to the power 0 is equal to 1, and anything to the power of 1 is itself. And of course, if we've got x times, this isn't the decimal point, it's the dot product, it's like means multiply, so otherwise it'd look like another x. X times x is equal to x squared, of course. If we had x times x again, that would be equal to x to the power 3, or x cubed. Coming further on from that, if we have powers that are negative, anything to the power of minus 1 is 1 over the anything, so x to the minus 1 is 1 over x. If we had x to the minus 2, it's still 1 over, but it's 1 over x squared. If we add x to the minus 3, that's equal to 1 over x cubed, and so on. Okay, so this is the power of 0, that's the power of 1 squared cubed, and then we've got 1 over is the minus 1, 1 over x squared is x to the minus 2, and 1 over x cubed is x to the minus 3. And if you're wondering where x to the 0 equals 1 comes from, like I used to, I didn't really get it at all when I was at school. If you've got, say, x cubed divided by x cubed, well, what that really is x times x times x all over x times x times x, and they all cancel. Everything cancels down, and what it's equal to is 1. But what we're also told to do when we divide by the same variable is that would become x to the 3 minus 3. We take away the denominator power from the numerator power, and of course that's equal to 1, but it's also equal to x to the 0. So that's why x to the 0 is equal to 1. So I thought I'd just go over that quickly. The next thing we might be asked about is like to differentiate, say, x to the half. It may be given to us as the square root of x, because the square root of x is x to the half. The cubed root of x, where something times something times something equals x, we'd write that as x to the third. Well, yeah, the number of the root is the number on the denominator of the fractional power. Then you may end up with like x to the minus a half, and because it's minus, it's 1 over, and x to the half is the square root of x. So you may be given questions in all different sort of formats, so just be aware, and it may be worth your while reading up at mathscentre.ac.uk for fractional and negative powers. So we may as well jump in and try and work out some derivatives of things that we may be given. For instance, you may have function y is equal to 1 over x squared, and it may ask you to find dy dx, so find how y changes as x changes. But it's a little bit difficult here because you can't really see what the power is of x. So what we'd rewrite the original function y is equal to x to the minus 2, and now it's much easier to find dy dx or y prime, because remember, when you've got ax to the n, to find a derivative you bring the n down and you take 1 off it. So let's bring the power down, and even though it's negative we still bring it down, so it becomes minus 2 times x, and instead of x to the minus 2 we take 1 away from that power, so minus 2 take away another 1 is minus 3. So the derivative is equal to minus 2 x to the minus 3. Another example, if we've got y is equal to 1 over x squared, take away 1 over x cubed, and it says, you know, find the first derivative dy dx. We'll do the same again, rewrite it so that you can recognize the powers. So y is equal to x to the minus 2, take away x to the minus 3. So dy dx is equal to, for the first term, minus 2 lots of x to the minus 3, because we took one off the power, then there's a minus sign. And for the second term, we still have to bring the power down, and that power is minus 3, and it goes in front of the x, and then you take one off the power, which will become minus 4. So to tidy it up, dy dx for that second example is equal to minus 2 x to the minus 3, but we've got minus take away a minus. That's like saying it isn't negative, so it must be a plus. So plus 3x to the minus 4, and that is the answer for that one. And we'll just do one more. You may be asked to find a derivative of, say, y equals the fourth root of x cubed, and they may ask you to find y prime. Now, the reason this is hard is not because of calculus, it's because of the powers and, you know, fractional powers and indices. So you want to read up on them if you're worried about that, but the calculus part is always the same. It's just in the form ax to the n. So let's rewrite it. Well, the fourth root of x cubed is going to be x cubed all to the quarter, if you like, so it's x to the 3/4. So therefore y prime, or dy dx, remember, bring the power down in front, all of it, so it's 3/4 of x, and then we need to take a 1 away from the power, so we've got 3/4 take away 1, so that comes out as 3/4 of x. And remember, 3/4 take away 1, remember 1 is equal to 4/4, so we've got x to the 3/4 take away 4/4, 3/4 take away 4/4 is minus 1/4, and that's an acceptable way of presenting it. You could do roots and negative stuff and have the fourth root sign, but I think that's a fine way to present it. So it's just a few examples on negative and fractional roots, and any comments, just leave them below. Alright, thanks.